Before there were telescopes, before there were books, before there were cities that scraped the sky, there were eyes lifted upward in wonder. In the velvet darkness of prehistoric nights, when fire was humanity's only companion and silence stretched, like eternity across untamed lands, our ancestors discovered something profound in the dance of distant lights. They found stories written in starfire, calendars carved in celestial motion, and gods breathing in the rhythm of planets. This is the forgotten symphony of ancient astronomy, where every constellation held a secret, every eclipse carried prophecy, and every wandering star whispered the deepest truths of existence. Tonight, we drift back to that primal moment when humanity first reached toward the infinite, and found the infinite reaching back. If this journey into history gently moves you, take a second to like, share, and subscribe. It helps more sleepy minds find their way here. By the way, where in the world are you listening from? What time is it where you are? Drop a comment before you drift off. We read every single one, somewhere in the African savannah, perhaps 40,000 years ago. A human being looked up at the night sky and experienced something that would forever change our species. It was not the first time someone had gazed upwards. Survival had always demanded awareness of day and night, of seasons and weather. But this moment was different. This was the birth of wonder, the first spark of a cosmic curiosity that would eventually build pyramids, calculate eclipses, and send metal birds beyond the very stars that once seemed impossibly distant. The sky that greeted our ancestors bore little resemblance to the pale, light-polluted dome we know today. It was a cathedral of darkness pierced by thousands upon thousands of brilliant points, a canvas so rich with detail that it seemed alive, breathing with the slow pulse of celestial mechanics. The Milky Way stretched overhead like a river of silver dust, so bright it cast shadows on the ground below. Venus blazed like a celestial torch, while Mars glowed with its distinctive ruddy fire that would later inspire countless myths of war and passion. In this pristine darkness, patterns emerged with startling clarity. The Big Dipper traced its familiar shape across northern skies, while in the south, the Southern Cross provided navigation and inspiration for entirely different cultures. Our ancestors began to see animals in the stars, bears and hunters, swans and scorpions, lions and fish. These weren't merely random groupings of distant suns. They were the first attempts to organize the infinite, to find meaning in the cosmic chaos that surrounded Earth like a jeweled sphere. The moon, that faithful companion, became humanity's first clock and calendar. Its phases provided the earliest reliable measure of time beyond the simple cycle of day and night. New moon brought darkness for hunting and stealth. Full moon illuminated nocturnal gatherings and ceremonies. The waxing and waning spoke of birth, growth, death, and renewal cycles that governed not just the tides but the very rhythm of life itself. Women noticed their bodies synchronized with lunar phases. Farmers observed how certain seeds sprouted better when planted during specific moon quarters. The moon was not just a light in the sky. It was a partner in the dance of existence. As generations passed, this celestial awareness deepened into something approaching science. The careful observers among our ancestors began to notice that some stars remained fixed in their relationships to one another, turning as one great wheel around a central point, what we now call Polaris, the North Star. But other lights moved. These wandering stars, the planets, traced complex loops across the stellar background, sometimes racing forward, sometimes slowing, sometimes even appearing to reverse direction in their courses. The ancient mind perceived the heavens as a vast scroll upon which the gods wrote their intentions. Every unusual celestial event, comet's sudden appearance, an eclipse's dramatic shadow, the rare alignment of planets, was interpreted as divine communication. But this was not primitive superstition. It was humanity's first attempt to create a universal language, a system of meaning that could transcend the barriers of tribe and tongue. Consider the awe and terror that must have gripped our ancestors during a total solar eclipse. The sun, that reliable source of light and life, would begin to disappear as if devoured by an invisible cosmic beast. Day would turn to night in minutes. Birds would return to their roosts in confusion. The temperature would drop, and for a few precious moments, the sun's corona would blaze around the moon's silhouette like silver fire. Stars would appear in the daytime sky. Then, as suddenly as it began, the spectacle would end, and the sun would emerge triumphant once more. These eclipses became central to the astronomical traditions of countless cultures. The ancient Chinese spoke of a celestial dragon devouring the sun. Nordic peoples told of wolves swallowing the solar orb. In India, the demon Rahu was said to consume the sun in revenge for being exposed as a deceiver at the churning of the cosmic ocean. Each culture created its own mythology around these events. But beneath the diverse stories lay a common truth. Humanity was beginning to predict and understand these phenomena. The earliest astronomers were not merely observers, they were mathematicians, developing complex systems to track and predict celestial events. They had to be. Their survival, and the survival of their communities, often depended on accurate knowledge of seasonal changes. When to plant crops, when to expect floods, when to prepare for winter. All of these crucial decisions relied on reading the sky correctly. In Mesopotamia, the birthplace of recorded history, temple priests became humanity's first professional astronomers from the tops of Ziggurats. These ancient scientists maintained careful records of celestial movements on clay tablets. They tracked the paths of planets with remarkable precision, developing mathematical models that could predict future positions. The Venus tablet of Ammisaduqa, dating to around 1600 BCE, records the movements of Venus with such accuracy that modern astronomers use it to refine our understanding of ancient chronology. These Mesopotamian astronomers discovered something profound. The heavens moved according to predictable patterns. What seemed random and chaotic actually followed mathematical laws. This was perhaps humanity's first encounter with the concept that the universe itself was rational, that beneath apparent chaos lay an elegant order waiting to be discovered and understood. Across the misty landscapes of prehistoric Europe, massive stone monuments rose from the earth like fingers pointing toward eternity. Stonehenge, Newgrange, Karnak, Avaberith, these were not merely ceremonial sites or burial grounds, though they served those purposes too. They were astronomical computers carved in stone, precision instruments designed to capture and measure the movements of sun, moon, and stars across the endless cycle of years. Stonehenge, perhaps the most famous of these ancient observatories, reveals its secrets slowly to modern archaeoastronomers. The great trilithons, those towering stone doorways, frame the rising sun on the summer solstice with mathematical precision. But this alignment is only the beginning. The entire complex serves as a vast three-dimensional calendar, tracking not just the sun's annual journey, but the more complex 18.6-year cycle of the moon's movements against the stellar background. The builders of Stonehenge possessed knowledge that wouldn't be formally rediscovered until the development of modern astronomy. They understood that the moon's orbit is tilted relative to Earth's orbit around the sun, creating a complex cycle of maximum and minimum moonrises and moonsets. They knew that this cycle, when combined with the sun's annual path, creates patterns that repeat every 56 years, precisely the number of Aubrey holes that ring the monument's outer circle in Ireland. The passage tomb of Newgrange demonstrates even more sophisticated astronomical alignment. Built around 3200 BCE, making it older than Stonehenge and the Egyptian pyramids. This Neolithic monument incorporates a feature called a roof boxer, carefully engineered opening above the entrance passage. For just a few days around the winter solstice, the rising sun shines directly through this opening, sending a beam of golden light down the 60-foot passage to illuminate the burial chamber at the monument's heart. The precision required for this alignment is extraordinary. The builders had to account not only for the sun's position on the winter solstice, but also for the gradual changes that occur over centuries and millennia. They were working with a level of astronomical sophistication that speaks to generations of careful observation and mathematical calculation. Knowledge passed down through oral tradition with remarkable accuracy. These stone circles and passage tombs represent something profound about our ancestors' relationship with the cosmos. They saw themselves not as separate from the universe, but as part of its grand design. Their monuments were attempts to create harmony between earth and sky, to build structures that participated in the cosmic dance rather than merely observing it from the outside. Along the banks of the Nile, where the desert meets the fertile river valley, ancient Egyptian civilization developed one of history's most sophisticated astronomical traditions. The pyramids of Giza, those eternal monuments to pharaonic power, conceal within their massive structures a level of astronomical knowledge that continues to astonish modern researchers. The Great Pyramid, built for the pharaoh Khufu around 2580 BCE, serves as a three-dimensional star map carved in limestone. Its four sides align with the cardinal directions to within a fraction of a degree of precision that would be impressive even by today's standards. The pyramid's internal passages point toward specific stars that held deep significance in Egyptian cosmology. The so-called King's Chamber has shafts that align with Orion and Draco, while the Queen's Chamber shafts point toward Sirius and the Little Dipper. But the pyramid's astronomical sophistication goes far beyond these stellar alignments. The monuments' proportions encode mathematical relationships that reflect the builder's understanding of Earth's dimensions and celestial mechanics. The ratio of the pyramid's perimeter to its height approximates the mathematical constant pi, while other measurements suggest knowledge of Earth's circumference and the precession of the equinoxes that slow 26,000 years wobble in Earth's axis. That causes the apparent positions of stars to shift gradually over time. The Egyptians' astronomical knowledge was deeply intertwined with their religious beliefs and their understanding of death and rebirth. The star Sirius, which they called Sopdet, was associated with the goddess Isis and marked the beginning of their new year. The heliacal rising of Sirius, its first appearance in the dawn sky after a period of invisibility, coincided with the annual flooding of the Nile, the event upon which Egyptian civilization depended for its survival. This connection between Sirius and the Nile flood was not mere correlation. It was the foundation of the Egyptian calendar and agricultural system. Egyptian astronomer priests maintained careful records of Sirius's behavior, developing a sophisticated understanding of the star's apparent movement against the background of other celestial objects. They knew that Sirius follows a cycle of approximately 1,460 years relative to their 365-day calendar period they called the Sothic cycle. The Egyptian conception of the afterlife was fundamentally astronomical. The pharaoh's soul was believed to journey through the underworld each night with the sun god Ra, battling the forces of chaos before emerging triumphant with the dawn. The deceased king would also join the circumpolar stars, those that never set below the horizon, becoming part of the eternal cosmic order that governed both earthly and celestial realms. This stellar afterlife was not merely metaphorical. Egyptian tomb texts provide detailed descriptions of the soul's journey through various regions of the sky, complete with maps and guides for navigating the celestial landscape. The coffin texts and pyramid texts read like astronomical handbooks, filled with precise knowledge about star positions, planetary movements, and the complex relationships between earthly time and cosmic cycles. In the Fertile Crescent between the Tigris and Euphrates rivers, Babylonian astronomers developed perhaps the most mathematically sophisticated approach to celestial mechanics in the ancient world. Where other cultures saw gods and myths in the movements of planets, the Babylonians saw numbers patterns that could be captured in equations and used to predict future events with startling accuracy. The Babylonians inherited and expanded upon the astronomical traditions of their Sumerian predecessors, but they transformed observation into true science. They divided the zodiac into 12 equal segments of 30 degrees each, giving us the familiar 12-sign system still used in astrology today. More importantly, they developed sophisticated mathematical models for planetary motion that wouldn't be surpassed until the work of Copernicus and Kepler nearly 2 millennia later. Babylonian astronomical texts, written in cuneiform on clay tablets, reveal a level of mathematical sophistication that seems almost modern. They calculated the length of the year 2 within minutes of our current measurement. They predicted eclipses with remarkable accuracy, developing tables that could forecast these events decades in advance. Their mathematical model for the moon's motion incorporated an understanding of the moon's varying speed in its orbit that required careful observation and sophisticated calculation. The Babylonians were particularly fascinated by Venus, that brilliant wandering star that appears alternately as morning and evening star. They tracked Venus's complex 8-year cycle with obsessive precision, noting how the planet traces a 5-pointed star pattern against the background of the zodiac over this period. This Venus cycle became central to their understanding of cosmic harmony and mathematical beauty in celestial mechanics. What made Babylonian astronomy truly revolutionary was its predictive power. Unlike their predecessors, who primarily recorded and interpreted celestial events after they occurred, Babylonian astronomers could forecast future positions of planets, dates of eclipses, and other significant celestial events. This predictive capability gave them enormous prestige and influence, establishing astronomy as a profession with practical applications for agriculture, navigation, and state planning. The Babylonian approach to astronomy was fundamentally different from our modern scientific method. They were less concerned with explaining why planets moved as they did than with describing how they moved and when specific events would occur. Their mathematical models were phenomenological rather than theoretical. They worked even without underlying physical explanations for the phenomena they described. This mathematical tradition profoundly influenced later astronomical developments. When Greek scholars encountered Babylonian astronomical texts, they were amazed by the precision and predictive power of these ancient calculations. The Greeks would eventually provide physical models and geometric explanations for planetary motions, but they built upon the mathematical foundation laid down by Babylonian astronomers centuries earlier. As we drift towards sleep, carried by these ancient currents of celestial knowledge, we must acknowledge what has been lost. For every astronomical tradition we can reconstruct from surviving monuments and texts, countless others have vanished without trace. Entire civilizations developed sophisticated understanding of cosmic cycles, built observatories, trained generations of stars, only to have their knowledge dissolve into the silence of forgotten centuries in the Amazon rainforest. Archaeologists have discovered the remains of complex societies that flourished for millennia before European contact. These cultures left behind massive earthworks and sophisticated agricultural systems, but almost no record of their astronomical knowledge. Did they, like so many other peoples, develop their own methods for tracking celestial cycles? Did they see different patterns in the same stars that guided their agricultural practices and religious ceremonies? We may never know. The oral traditions of indigenous peoples around the world preserve fragments of ancient astronomical wisdom. Australian Aboriginal Dreamtime stories encode knowledge about stellar positions and celestial events that stretches back thousands of years. Native American traditions speak of star knowledge passed down through countless generations. African cultures maintain complex relationships with celestial cycles that govern everything from agricultural practices to social organization, but oral tradition is fragile. Each generation that passes without transmitting this knowledge represents an irreplaceable loss. Languages disappear, carrying with them unique ways of understanding and organizing celestial phenomena. Traditional ecological knowledge, intimately connected with astronomical cycles, vanishes as modernization disrupts ancient patterns of life. Even literate civilizations have lost astronomical knowledge. The Great Library of Alexandria, that legendary repository of ancient learning, contained countless astronomical texts that have been lost forever. Medieval Islamic astronomers preserved and expanded upon Greek and Babylonian traditions, but many of their works survive only in fragmentary form. The astronomical knowledge of Maya civilization, encoded in their sophisticated calendar systems and eclipse tables, was largely destroyed by Spanish conquistadors who saw it as pagan superstition. Sometimes the silence is more mysterious. The Antikythera mechanism, that incredible bronze computer discovered in a Mediterranean shipwreck, demonstrates a level of astronomical and mechanical sophistication that seems almost impossible for its era. Dating to around 100 BCE, this device could predict eclipses, track planetary positions, and calculate the dates of Olympic Games decades in advance. Yet we have almost no other evidence for the tradition of mechanical astronomy that must have produced such a sophisticated instrument. The mechanism's discovery raises haunting questions about what else has been lost. If ancient Greek craftsmen could build such precise astronomical computers, what other technological achievements vanished without trace? How many times has human knowledge reached impressive heights only to be forgotten when civilizations fell? Libraries burned, or traditions were interrupted by war, disease, or cultural transformation. As we close this first part of our journey through forgotten astronomy, we rest in the contemplation of these lost voices, the unnamed observers who first divided the sky into patterns, the anonymous mathematicians who calculated celestial cycles, the forgotten builders who aligned monuments with stellar precision. Their individual names may be lost, but their legacy surrounds us every night when we look up at the same stars that once guided their eyes toward understanding. In sleep, we join them in that timeless moment of wonder when human consciousness first reached toward the infinite cosmos and found itself reflected there. Tomorrow night, when you next glimpse the stars through your window, you carry within you the accumulated wisdom of 40,000 years of stargazing, the inherited gift of humanity's longest-running scientific tradition. The stars continue their ancient dance, indifferent to human memory, yet forever changed by human attention. In their light, we glimpse the eternal conversation between mind and cosmos that began when our ancestors first looked up in wonder and will continue as long as conscious beings remain to marvel at the night sky's endless mystery. And so they began to build, not just shelters against the wind and rain, but monuments to the eternal dance above stone circles that breathed with the rhythm of seasons, temples that caught the first light of distant suns, calendars carved from granite and obsidian that would outlast empires yet unborn. These were humanity's love letters to the cosmos, written in architecture and astronomy. In careful angles and patient observation, the builders came in waves across millennia, each generation adding their voice to the celestial symphony. They were farmers who needed to know when floods would come, priests who sought to commune with star gods, mathematicians who found poetry in numbers, and dreamers who simply could not look away from the night sky's endless mystery. Their hands shaped stone with the same reverence others reserved for prayer. In the mist-trapped hills of ancient Britain, where fog clung to valleys like forgotten dreams, the first stone circles began to rise. Not the grand monuments that would come later. Those would take centuries more of accumulated wisdom, but humble arrangements of local stone, placed with careful intention by hands that shook not from fear but from awe. The circle at Nabta Playa, older than Stonehenge by millennia, stood in what is now the Sahara Desert, but was then a place of seasonal lakes and grass-covered plains. Here, 6,000 years before the pyramids cast their shadows across sand, nomadic peoples gathered stones not much larger than a person could carry. Arranging them in patterns that spoke to the sky, they came during the summer monsoons, when rain transformed the desert into temporary paradise. Families who had scattered across vast distances during the dry season would converge around the sacred stones, bringing with them not just goods for trade, but observations gathered across months of travel. An elder might have noticed that a particular star had shifted its position relative to the horizon. A young herder could report seeing Venus rise before dawn for the first time in memory. These observations were more than casual interest, they were survival. The stones of Nabta Playa were arranged to track the summer solstice, marking the time when the rains would come and the desert would bloom. But more than this, they tracked the subtle progression of the stars themselves, the slow dance called precession that shifts the entire celestial sphere over periods of thousands of years. The builders of Nabta Playa discovered something that would not be fully understood by modern astronomy until the 20th century, that the stars themselves were not fixed, but participated in vast, slow cycles that spanned millennia. They encoded this knowledge in stone, creating a calendar that could function across generations, a bridge between the fleeting human lifespan and the eternal patience of the cosmos. As centuries passed and the climate changed, driving the lake peoples away from their stone circles, the knowledge they had gained spread across Africa and beyond. Fragments of their astronomical understanding would surface in later civilizations, in the pyramid texts of Egypt, in the mud-brick ziggurats of Mesopotamia, in the careful orientation of temples from Nubia to the Mediterranean, across the ocean, in the river valleys of the Americas. Other builders were raising their own monuments to the Mississippian peoples, long before the arrival of Europeans. Constructed earthen mounds whose orientations spoke to celestial events with startling precision. At Cahokia, near what would become St. Louis, they built a complex that rivaled London in its size and sophistication. The centerpiece was Monk's Mound, a vast pyramid of earth that rose in 4 terraces toward the sky. But it was not the mound itself that held the astronomical secrets. It was the careful arrangement of wooden posts that surrounded it, a timber henge that archaeologists would later call the American Woodhenge. These posts, massive cedar trunks, stripped of bark and sunk deep into the prairie soil, formed a circle whose diameter matched that of Stonehenge with uncanny precision. But where the British monument tracked the sun and moon in their daily and monthly cycles, the American Woodhenge was attuned to more subtle rhythms, the points where certain stars would rise throughout the year, the precise moments of equinox and solstice, the complex interweaving of lunar and solar calendars. The builders of Cahokia were not only astronomers, but agriculturalists on a scale that transformed entire landscapes. They cultivated vast fields of corn, beans, and squash in patterns that followed celestial timing. The planting of corn was timed not just to the last frost, but to the heliacal rising of particular star groups. The harvest festivals were synchronized with the appearance of other stellar markers, creating a calendar that wove together practical farming, knowledge with spiritual connection to the cosmic order. What made their system remarkable was its flexibility. Unlike stone monuments that, once built, remained fixed in their orientations, the wooden posts of Cahokia could be moved and reconfigured as the builders refined their understanding of celestial mechanics. Archaeological evidence suggests that the Woodhenge was rebuilt and realigned multiple times over the centuries, each iteration representing a more sophisticated grasp of astronomical cycles. They understood, as the builders of Nabta Playa had understood, that astronomy was not a static science, but a living practice that required constant observation and adjustment. The stars might appear fixed from the perspective of a single human lifetime, but across generations, their subtle movements became apparent to patient watchers, who passed their knowledge from elder to student in unbroken chains of learning. In the dense jungles of Cambodia, where morning mist rises like incense from ancient stone, the Khmer builders created something unprecedented in human history. An entire city designed as a three-dimensional map of the cosmos. Angkor was not merely a capital or a religious center. It was an astronomical computer built at the scale of architecture, where every temple, every causeway, every reflecting pool served as a component in a vast celestial calculation. The construction of Angkor spanned centuries, each successive king adding new temples and complexes that expanded the astronomical functions of the city. But it was Angkor Wat, built in the early 12th century, that represented the culmination of Khmer astroarchitectural knowledge. The temple complex was oriented not just to capture the light of the rising sun on the spring equinox, though. It did this with breathtaking precision, but to encode multiple celestial cycles in its proportions and alignments. The builders understood that the temple would serve as more than a place of worship. It would be a teaching device, a way of passing astronomical knowledge to future generations through the medium of stone. The central tower of Angkor Wat rises to a height that corresponds to the number of days in the lunar month when measured. In the local unit of length, the number of steps leading to various levels of the temple encodes the cycles of Venus, the periods of solar eclipses, the precession of the equinoxes. But perhaps most remarkably, the entire layout of Angkor mimics the slow wobble of the Earth's axis that causes the phenomenon of precession. The city's temples are arranged in patterns that shift their astronomical functions over millennia, so that a temple aligned to one celestial event in the 12th century would centuries later align to a different but equally significant astronomical phenomenon. This was architecture designed not for a single generation but for the ages. The Khmer builders were thinking in terms of millennia, creating a city that would continue to function as an astronomical instrument long after their civilization had faded into memory. They embedded their knowledge so deeply in stone that modern astronomers are still discovering new alignments and calculations hidden within the temple complexes. The priests who served in these temples were not merely ritual specialists, but trained astronomers who maintained complex calendars that tracked multiple celestial cycles simultaneously. They calculated the dates for religious festivals, the timing of agricultural activities, the auspicious moments for royal ceremonies, and the optimal times for construction projects. Their astronomical knowledge was inseparable from their spiritual practice, woven into a cosmology that saw the movements of celestial bodies as the visible manifestation of divine order. The library at Nalanda in ancient India housed scrolls and palm leaf manuscripts that preserved astronomical knowledge from across Asia. Buddhist monks and Hindu mathematicians worked side by side, translating texts from Sanskrit to Chinese, from Arabic to Tibetan, creating a vast repository of celestial wisdom that drew scholars from as far away as Greece and Persia. It was here that the great Indian mathematician Brahmagupta refined the concept of zero and developed mathematical techniques for calculating planetary positions with extraordinary accuracy. His work on the motion of celestial bodies influenced not only Indian astronomy, but would later be transmitted to the Islamic world, and from there to medieval Europe, becoming one of the foundational texts of mathematical astronomy. The astronomical texts preserved at Nalanda described techniques for eclipse prediction that were accurate to within minutes, methods for calculating the true positions of planets that accounted for their elliptical orbits centuries before Kepler, and trigonometric functions that made possible the construction of detailed star maps and astronomical instruments. But beyond the mathematical sophistication, these texts preserved something equally valuable: the sense of wonder and reverence that the ancient astronomers felt toward the cosmos. They wrote not just of calculations and predictions, but of the spiritual significance of celestial phenomena, the way that understanding the movements of the stars could deepen one's comprehension of the underlying order of existence. In the golden age of Islamic civilization, when Baghdad was the intellectual center of the world and scholars translated Greek texts while developing new mathematical tools, the Caliph Al-Mun commissioned something unprecedented: a series of observatories that would span the Islamic world from Spain to Central Asia, each one equipped with instruments of bronze and marble that could measure celestial positions with previously unimaginable precision. The House of Wisdom in Baghdad became the nerve center of this vast network Here, astronomers like Al-Battani made observations that corrected Greek calculations of the length of the solar year, while Al-Biruni measured the circumference of the Earth with an accuracy that would not be surpassed for centuries. They developed new trigonometric functions, refined the astrolabe into an instrument of breathtaking sophistication, and created star catalogues that mapped the heavens with meticulous care. The observatory at Samarkand, built by the Ulugh Beg in the 15th century, housed a vast meridian arc, a curved track built into a hillside that allowed astronomers to measure the positions of stars and planets as they crossed the meridian with unprecedented accuracy. The Zegis Sultani, the star catalogue produced at Samarkand, was so precise that it remained the standard reference for stellar positions for centuries. But these Islamic astronomers were not merely concerned with measurement and calculation. They saw their work as a form of worship, a way of contemplating the perfection of divine creation through the study of celestial mechanics. Their astronomical poetry spoke of the stars as letters in a cosmic book, the movements of planets as verses in a celestial poem that revealed the nature of existence itself. They understood that astronomy was both a practical science and a spiritual discipline. The same mathematical techniques that allowed them to calculate prayer times and determine the direction of Mecca could also reveal the elegant patterns that governed the motion of comets, the cycles of eclipses, the slow wobble of the Earth's axis that caused the stars to shift their positions over millennia. The great astronomer Al-Sufi, working in the 10th century, created a star atlas that combined Greek constellation figures with Arab star names, producing a synthesis that would influence star charts for 1,000 years. His Book of Fixed Stars was not merely a catalogue, but a work of art, with detailed illustrations that showed the constellations as they appeared both from Earth and as they would look if viewed from the outside of the celestial sphere. In the high mountains of Peru, where the air is thin and stars shine with crystal clarity, the Inca built a different kind of observatory. Machu Picchu, perched impossibly on its mountain ridge, was oriented to capture not just the rising sun, but the seasonal movements of stellar constellations that were invisible from lower altitudes. The Intihuatana stone, carved from living bedrock, at the highest point of the citadel, served as a sophisticated sundial that could track the sun's daily and seasonal movements with remarkable precision. But it was more than a timekeeper, was a sacred focal point where the Inca believed the sun was symbolically tied to the earth, preventing it from wandering away into the cosmic darkness. The Inca astronomers, working without written language, but with extraordinary observational skills, developed a calendar system that tracked both solar and lunar cycles while accounting for the complex movements of Venus and other planets. They identified and named dozens of stellar constellations, many of which corresponded not to the bright star patterns familiar to Northern Hemisphere observers, but to the dark lanes of cosmic dust that create shadowy shapes against the Milky Way. Their astronomical knowledge was inseparable from their agricultural practices and religious ceremonies. The appearance of particular constellations marked the times for planting and harvest. For religious festivals and royal ceremonies, the Inca understood that they lived in a cosmos where every celestial movement had terrestrial significance, where the patterns of the stars were intimately connected to the rhythms of life on Earth. The Spanish conquistadors who destroyed the Inca Empire were largely blind to the sophisticated astronomical knowledge they were obliterating. They saw only pagan superstition where the Inca saw cosmic order, only primitive star worship where there existed a complex understanding of celestial mechanics that rivaled anything developed in Europe or Asia. Yet fragments of Inca astronomical knowledge survived, preserved in the memories of mountain peoples who continued to plant by stellar calendars and tell time by the movements of constellations that their ancestors had named thousands of years before. In remote villages of the Andes, farmers still watch for the heliacal rising of the Pleiades to determine the timing of potato planting, following traditions that reach back to the very origins of agriculture in the New World. Across the vast Pacific, where islands are separated by thousands of miles of open ocean and the horizon stretches endlessly in all directions, The Polynesian navigators developed perhaps the most sophisticated system of celestial navigation ever devised. They could guide their outrigger canoes across trackless waters using only the stars, the swells, the behavior of birds, and an intimate knowledge of how the sky changes as one moves across the Earth's surface. The star compass used by these master navigators was not a physical instrument, but a mental map of extraordinary complexity. They memorized the rising and setting points of hundreds of stars, understanding how each celestial body would appear at different latitudes and seasons. They knew which stars would pass directly overhead at particular islands, creating invisible pathways across the ocean that could be followed with precision. But their navigation system went far beyond simple star positions. They understood the relationship between celestial movements and ocean swells, recognizing how waves reflected off distant islands could be detected by skilled navigators hundreds of miles away. They knew the flight patterns of different seabirds and could read the color of clouds to detect the presence of land beyond the horizon. The training of a master navigator took decades and required not just memorization, but a deep, intuitive understanding of the ocean as a living system connected to the movements of the sky. Young students would spend years learning to feel the subtle motions of swells while lying in the bottom of a canoe, developing a bodily awareness of the ocean's rhythms that complemented their intellectual knowledge of stellar positions. They created charts, abstract maps made of bamboo and shells that represented not the physical geography of islands, but the patterns of swells and currents that connected different parts of the ocean. These charts were not literal representations, but mnemonic devices that helped navigators remember complex three-dimensional patterns of water movement that changed with seasons and weather. The astronomical knowledge of Polynesian navigators was embedded in songs and stories that preserved precise information about star positions, ocean conditions, and seasonal patterns across generations. A single navigation chant might contain detailed information about the rising times of dozens of stars, the seasonal behavior of trade winds, the breeding cycles of fish that could be used to determine position, and the traditional names of stars in multiple languages. When European explorers first encountered Polynesian navigators, they were astounded by the accuracy of their methods. Captain James Cook wrote in his journals about meeting navigators who could draw accurate maps of island chains across thousands of miles of ocean, who knew the positions of islands they had never visited but had learned about through traditional knowledge passed down through generations of seafarers. In the harsh beauty of the Arctic, where winter nights last for months and the aurora borealis paints the sky in curtains of green and gold, the Inuit developed their own relationship with the celestial sphere. They created detailed star maps that served not only for navigation across the featureless ice, but for timekeeping. Through the long polar night, the Inuit identified constellations that were completely different from those known to southern peoples. Star patterns that were visible only from high northern latitudes. They told stories about these constellations that encoded practical information about seasonal changes, weather patterns, and the behavior of Arctic animals. The appearance of particular stars marked the times when seals would be most abundant, when the ice would be safe for travel, when the long summer daylight would begin to return. Their astronomical knowledge was intimately connected to survival. In one of Earth's most challenging environments, the position of stars could indicate wind direction, the stability of ice, the likelihood of storms. During the months of polar night, stellar positions provided the only reliable way to maintain orientation across vast expanses of snow and ice that offered few landmarks. The Inuit also developed sophisticated understanding of the aurora, recognizing patterns in its appearance that correlated with weather changes and seasonal transitions. They understood that the northern lights were not simply random displays, but followed cycles that could be predicted and interpreted. Their traditional knowledge included detailed observations of how aurora activity changed with the phases of the moon, with the time of year, with the appearance of particular stars. This knowledge was preserved in an oral tradition that stretched back thousands of years, encoded in songs and stories that were passed from elder to student in the context of actual travel and hunting expeditions. Young Inuit learned to read the sky not through abstract study but through practical application, developing skills that were literally matters of life and death in the Arctic environment. The coming of modern technology, GPS navigation, weather, satellites, mechanized transportation has largely replaced traditional astronomical knowledge in the Arctic, as it has in most parts of the world. But in remote communities, elders still remember the old ways, still know how to read the sky with eyes that were trained to see patterns that escape the notice of those who have never learnt to look. And in the southern reaches of the planet, where the continent of Antarctica stretches white and empty under skies that show stars invisible from the north, the ancient knowledge of celestial navigation continues to prove its worth. Modern explorers venturing into regions where electronic devices fail have rediscovered the reliability of stellar navigation, the way that patient observation of the sky can provide orientation and timekeeping that no technology can improve. Upon the stars that guided ancient astronomers across deserts and oceans, that marked the seasons for farmers and the hours for priests, that served as clocks and calendars and compasses for civilizations that rose and fell across millennia. These same stars continue their eternal dance above us, patient and reliable, waiting for eyes that know how to read their ancient language, waiting for minds that remember how to listen to their timeless wisdom. In observatories built of stone and bronze, in temples aligned to capture the light of particular stars, in the careful arrangements of wooden posts and earthen mounds, in the songs of navigators and the calculations of mathematicians' priests, humanity left a record of its first attempts to understand the cosmos. These were not primitive superstitions, but sophisticated sciences, ways of knowing that integrated careful observation with practical application, spiritual insight with mathematical precision. The knowledge accumulated in these ancient observatories laid the foundation for all subsequent astronomy, providing the mathematical tools and observational techniques that would eventually allow humanity to understand its place in an expanding universe filled with billions of galaxies. The patient star watchers who built Stonehenge and Angkor Wat, who calculated eclipses in Baghdad and navigated by starlight across the Pacific, were the first scientists, the pioneers, who showed that the universe could be understood through careful observation and mathematical analysis. Yet something was lost, as well as gained, in the transition from ancient to modern astronomy. The sense of personal connection to the cosmos, the feeling that human life was intimately connected to celestial cycles, the understanding that astronomical knowledge was not merely technical information, but spiritual wisdom. These aspects of ancient star wisdom have largely disappeared from contemporary science, preserved now mainly in the half-remembered traditions of indigenous peoples and the reconstructed knowledge of RCHAEO astronomers. As the builders of ancient observatories understood, astronomy is more than the study of distant objects. It is a way of locating ourselves in the vastness of space and time, of understanding our kinship with the stars that forge the elements of which we are made, of recognizing the cosmic processes that govern everything from the rhythm of tides to the cycle of seasons to the slow evolution of galaxies across billions of years. The temples and stone circles, the star charts and navigation songs, the mathematical calculations and mythological strozol of these were different expressions of the same fundamental human impulse, the need to understand our place in the cosmos, to find meaning and pattern in the apparent chaos of existence, to connect the brief span of human life with the eternal movements of stars and planets that wheel overhead in their ancient, predictable, beautiful dance. They sailed by the breath of stars, guided by whispers older than memory, carrying within their souls the secret mathematics of infinity. The vast Pacific Ocean stretches across 1/3 of our planet's surface, a seemingly endless expanse of blue that would challenge even modern navigators with GPS and satellites. Yet across these waters, thousands of years ago, sailed the most accomplished celestial navigators humanity has ever known. The Polynesian wayfinders possessed a knowledge so profound, so intimately connected to the rhythms of the cosmos, that they could traverse thousands of miles of open ocean with nothing but their understanding of the stars, the waves, and the subtle signs written in the sky. ***, these master navigators, known as Palu in the Marshall Islands and Palu in Kiribati, carried within their minds libraries of astronomical knowledge that would make modern astronomers weep with envy. They knew intimately the rising and setting positions of over 200 stars, the seasonal paths of planets, and the subtle variations in celestial movements that occurred across different latitudes. Their knowledge was not written in books or carved in stone, but lived in the sacred. Oral traditions passed down through generations of star whisperers. The navigator's training began in childhood, when young boys and girls would lie on their backs on the beach, learning to recognize the star patterns that wheeled overhead. They memorized the star compass, a mental map of the night sky divided into 32 directional houses, each marked by the rising and setting points of specific stars. Altair, the bright star in the constellation Aquila, marked the direction to the northeast. Vega, the brilliant jewel of Lyra, indicated the way to the northwest. The Southern Cross, hanging like a celestial kite in the southern sky, pointed toward the south. But the stars were only one part of their cosmic toolkit. These navigators understood the ocean itself as a living, breathing entity that held its own astronomical secrets. They learned to read the telapa, the underwater lightning that flickered beneath the surface, caused by the bioluminescence of plankton disturbed by the motion of distant islands. They studied the patterns of waves, understanding how swells created by distant storms would bend and refract around unseen atolls, creating navigational signposts in the seemingly featureless sea. The most sacred knowledge belonged to the wave. Pilots, navigators who could feel the subtle undulations of the ocean through the hull of their vessels. They understood that waves reflected off islands created interference patterns that could be detected hundreds of miles away. By lying flat in the bottom of their outrigger canoes, these masters could sense the gentle rise and fall that indicated the presence of land beyond the horizon. They were human seismographs, attuned to the planet's most subtle vibrations. The Polynesian navigators possessed a deep understanding of the relationship between celestial mechanics and oceanic phenomena. They knew that the moon's phases affected more than just the tides. They influenced the behavior of seabirds, the patterns of fish migration, and even the phosphorescence of the water. During the dark of the moon, when the sky was at its clearest, they could navigate by the faint glow of the Milky Way, which they called the backbone of the sky. This celestial river served as a compass, its orientation changing throughout the night to provide directional guidance. The navigator's most precious possession was the wapipa, a bundle of objects that contained the distilled wisdom of generations. Inside might be found pieces of coral that had grown in specific patterns, shells that held the sound of distant reefs, and most importantly, the stick charts, intricate constructions of palm fronds and cowrie, shells that represented the wave patterns around various island groups. These charts were not maps in the Western sense, but three-dimensional models of the ocean's hidden geography, showing how waves behaved around different landmasses. The creation of a stick chart was a sacred act, requiring the navigator to spend years studying the wave patterns around a particular island or atoll. The straight sticks represented the major wave swells, while curved sticks showed how these waves bent around islands. The cowrie shells marked the locations of the islands themselves, but more importantly, they indicated the points where different wave systems converged, creating the navigational landmarks that guided voyagers across the open ocean. These master navigators understood seasonal navigation in ways that connected them intimately to the astronomical calendar. They knew that certain stars were visible only during specific months, and they planned their voyages accordingly. The appearance of the Pleiades cluster in the evening sky marked the beginning of the sailing season, when the trade winds would be favorable for long-distance voyages. The rising of Sirius, the brightest star in the night sky, indicated the approach of storms and the time to seek shelter. The training of a navigator was not merely technical but deeply spiritual. Students learned to enter a meditative state called moving meditation, where they became one with the motion of the ocean and the rhythm of the celestial sphere. In this state, they could sense direction and distance through subtle changes in the quality of light, the temperature of the air, and the patterns of clouds on the horizon. They learned to read the Taimata, the sky signs that indicated the presence of land, the subtle color changes in the underside of clouds that reflected the green of distant lagoons, the flight patterns of seabirds returning to their roosts, the sweet smell of vegetation carried on the wind. The navigators also possessed a sophisticated understanding of seasonal star calendars that would rival any modern ephemeris. They knew that the star Arcturus, which they called Anna-Tahua-Tah-Metua, would rise in the east at sunset during the month of November, marking the time for planting crops and preparing for the storm season. They tracked the movement of the Southern Cross throughout the year, understanding how its position relative to the horizon changed with the seasons and could be used to determine both direction and time of night. Perhaps most remarkably, these navigators understood the concept of star paths, the principle that certain stars, when followed throughout the night, would lead to specific destinations. They knew that if they sailed toward the rising point of Altair for the first part of the night, then adjusted their course to follow Vega as it moved across the sky, they could reach islands hundreds of miles away with remarkable precision. This knowledge required an understanding of stellar motion that was both mathematical and intuitive, combining precise observation with deep cosmic wisdom. The Polynesian navigators also mastered the art of dead reckoning. Using astronomical reference points, they could calculate their position and speed by observing the rate at which stars moved across the sky. Understanding that the celestial sphere's rotation provided a cosmic clock that could be used to measure time and distance traveled, They knew that in 1 hour, the stars would move 15 degrees across the sky, and they used this knowledge to estimate their speed and position throughout the night. Far from the tropical waters of Polynesia, in the cold northern seas where icebergs drifted like ghostly mountains and the aurora borealis painted the sky in sheets of green and gold, another civilization developed their own profound relationship with celestial navigation. The Vikings, those legendary seafarers who sailed from Scandinavia to the edges of the known world, possessed astronomical knowledge that allowed them to navigate the treacherous northern waters with remarkable skill and precision. The Viking navigators faced challenges unknown to their Polynesian counterparts. In the high latitudes of the North Atlantic, the sun barely rose above the horizon during winter months, and the familiar stars of the southern sky were hidden below the curve of the earth. The weather was harsh and unpredictable, with thick fogs and storms that could last for days, obscuring all celestial reference points. Yet somehow, these northern seafarers found their way across vast distances, reaching Iceland, Greenland, and eventually the shores of North America centuries before Columbus. The key to Viking navigation lay in their understanding of the sun's behavior in northern latitudes. They knew that the sun followed a much lower arc across the sky during winter months, and they developed techniques for finding direction even when the sun was hidden behind thick clouds. Their most famous navigational tool was the sunstone, a crystal of calcite or cordierite that could reveal the sun's position even on overcast days. When held up to the sky and rotated, these crystals would show patterns of polarized light that indicated the sun's direction, allowing navigators to maintain their course even during periods of complete cloud cover. The Vikings developed their own version of the star compass based on the unique characteristics of the northern sky. Polaris, the North Star, served as their primary reference point, but they understood that its position changed subtly as they sailed to different latitudes. They learned to use the constellation Ursa Major, the Great Bear, as a clock in the sky, knowing that it rotated around Polaris in a 24-hour cycle. By observing the position of the Big Dipper's handle relative to the North Star, they could determine the time of night and maintain their course. The Viking navigators also possessed a deep understanding of the sun's seasonal behavior. They knew the precise dates of the solstices and equinoxes, and they used this knowledge to plan their voyages. The summer solstice, when the sun barely set in the northern latitudes, provided the best conditions for long-distance navigation. During these white nights, they could sail continuously, using the sun's position to maintain their course around the clock. One of the most sophisticated aspects of Viking navigation was their understanding of latitude sailing. They knew that by sailing along a specific latitude, they could reach distant lands with remarkable accuracy. They would sail north or south until they reached the correct latitude, then turn east or west and follow that invisible line across the ocean. To determine latitude, they used simple but effective tools: a shadow stick that measured the sun's height at noon, or observations of the North Star's elevation above the horizon. The Vikings also developed techniques for navigating during the notorious northern fog. They learned to read the subtle signs that indicated the presence of land, the sound of waves breaking on distant shores, the smell of vegetation or smoke from human settlements, the behavior of seabirds, and the color of the water. They understood that ice reflected light differently than open water, creating a phenomenon called ice blink that could be seen from great distances. This knowledge allowed them to navigate around dangerous ice fields and find passages through the frozen seas. The Viking navigators possessed a sophisticated understanding of tidal patterns and their relationship to celestial mechanics. They knew that the tides were controlled by the moon's phases and position, and they used this knowledge to time their arrivals at shallow harbors and river mouths. They understood that spring tides, which occurred during the new and full moons, provided the highest water levels for navigating shallow coastal waters, while nape tides, during the quarter moons, offered the most stable conditions for anchoring. Perhaps most remarkably, the Vikings developed techniques for dead reckoning that took into account the unique characteristics of northern waters. They understood that ocean currents in the North Atlantic were influenced by the rotation of the Earth and the position of the Sun, creating predictable patterns that could be used for navigation. They knew that the Gulf Stream carried warm water northward along the European coast, while the Labrador Current brought cold water south along the American coast. By understanding these current systems, they could use them to aid their navigation and estimate their position. The Viking navigators also developed a sophisticated understanding of weather patterns and their relationship to celestial phenomena. They knew that certain cloud formations indicated approaching storms, and they learned to read the subtle signs in the sky that predicted changes in wind direction and intensity. They understood that the appearance of the aurora borealis could indicate magnetic storms that would affect their compass readings, and they developed techniques for navigating when their magnetic compass became unreliable. The knowledge of these northern navigators was preserved in their sagas, epic poems that contained not only stories of heroic voyages, but also detailed navigational instructions. These oral traditions described the sailing routes to distant lands, the locations of safe harbors, and the celestial signs that marked important waypoints. The sagas were more than entertainment. They were navigational manuals that preserved the accumulated wisdom of generations of seafarers. In the medieval Islamic world, as the light of learning flickered and dimmed in much of Europe, a golden age of astronomical knowledge flourished across the lands from Spain to India. The Islamic navigators and astronomers developed the most sophisticated mathematical tools for celestial navigation that the world had ever seen, creating instruments and techniques that would revolutionize maritime exploration and remain in use for centuries to come. The Astrolabe, perhaps the most elegant astronomical instrument ever created, reached its highest form of development in the hands of Islamic craftsmen and scholars. This brass marvel, no larger than a dinner plate, contained within its intricate engravings the entire celestial sphere. The astrolabe was simultaneously a star chart, a calculator, a clock, and a navigational computer. In the hands of a skilled navigator, it could determine the time of day or night, the direction of prayer toward Mecca, the dates of religious festivals, and, most importantly for our purposes, the position of a ship at sea. The Islamic astronomers understood that accurate navigation required precise mathematical calculations based on spherical trigonometry. They developed sophisticated methods for calculating the positions of celestial bodies, taking into account the precession of the equinoxes, the obliquity of the ecliptic, and the complex motions of the planets. Their astronomical tables, known as Ziggurats, contained thousands of entries giving the positions of stars and planets for any date and time, allowing navigators to predict celestial phenomena with remarkable accuracy. The great navigator Ahmad ibn Majid, known as the Lion of the Sea, exemplified the sophistication of Islamic celestial navigation. Born in the 15th century in what is now Oman, Ibn Majid authored over 30 works on navigation, including detailed sailing directions for the entire Indian Ocean. His knowledge encompassed not only the positions of stars and the use of instruments, but also the seasonal patterns of monsoons, the locations of coral reefs and dangerous shoals, and the cultural practices of the peoples who lived along the coasts he visited. Ibn Majid and his contemporaries developed the concept of the altitude navigation using the kamal, a simple but effective device consisting of a small wooden board with a knotted string attached. By holding the board at arm's length and aligning it with the horizon and a known star, navigators could measure the star's altitude above the horizon. The knots in the string corresponded to different latitudes, allowing the navigator to determine his position north or south of the equator with remarkable precision. The Islamic navigators possessed an intimate knowledge of the seasonal behavior of the monsoon winds, understanding that these predictable wind patterns were related to the sun's position and the changing temperatures of the land and sea. They knew that the southwest monsoon, which brought the sailing season to the Arabian Sea, began when the sun reached its highest point in the northern sky during the summer solstice. The northeast monsoon, which reversed the wind patterns, started when the sun moved south during the winter months. These navigators also developed sophisticated techniques for predicting the weather based on astronomical observations. They understood that the appearance of certain stars near the horizon could indicate approaching storms, and they learned to read the subtle signs in the sky that predicted changes in wind direction and intensity. They knew that the appearance of the star Canopus, which they called Suhail, marked the beginning of the date harvest and the end of the extreme summer heat. The Islamic tradition of celestial navigation was deeply intertwined with religious practice. The requirement to pray 5 times daily toward Mecca meant that every Muslim navigator needed to be able to determine direction with precision, regardless of his location. This religious obligation drove the development of increasingly sophisticated methods for finding the Qibla, the direction of prayer. Using astronomical observations and mathematical calculations, the great Islamic astronomers like al-Battani, al-Sufi, and Ibn al-Haytham made fundamental contributions to our understanding of celestial mechanics that directly improved navigational accuracy. They corrected errors in Ptolemy's star catalogue, discovered the precession of the equinoxes, and developed more accurate methods for predicting the positions of the sun, moon, and planets. Their work laid the foundation for the astronomical revolution that would later transform European navigation during the Age of Exploration. The Islamic navigators also developed the concept of lunar distances, a technique for determining longitude by measuring the angular distance between the moon and specific stars. This method, which required extremely precise observations and complex calculations, allowed navigators to determine their east-west position on the Earth's surface with unprecedented accuracy. The technique was so sophisticated that it remained in use by European navigators well into the 19th century. Long after the invention of the marine chronometer, the knowledge of Islamic navigation was preserved in a vast literature of navigational texts, astronomical treatises, and sailing directions. These works, written in Arabic, Persian, and other languages, contained detailed descriptions of sea routes, star positions, and navigational techniques. Many of these texts were beautifully illustrated with star charts, diagrams of navigational instruments, and maps of the known world. The information they contained was so valuable that these books were often considered state secrets, carefully guarded by the rulers, who controlled the lucrative trade routes of the Indian Ocean. The decline of Islamic navigation began in the 16th century, as European powers began to dominate the world's oceans. using navigational techniques that were largely based on Islamic knowledge. The Portuguese navigator Vasco da Gama, who found the sea route to India around the Cape of Good Hope, was guided by an Arab navigator who used traditional Islamic methods. The irony was not lost on contemporary observers. The knowledge that had been developed in the Islamic world was being used to break the Muslim monopoly on Indian Ocean trade. In the ancient Middle Kingdom, where the Yangtze River wound through valleys shrouded in morning mist, and the Yellow River carried the dreams of emperors to the sea, there developed a tradition of celestial navigation that was both profoundly practical and deeply mystical. The Chinese understanding of the cosmos was inseparable from their navigation techniques, creating a system that viewed the earth and sky as interconnected parts of a living, breathing universe governed by the eternal principles of yin and yang. The Chinese were the first civilization to develop the magnetic compass, a revolutionary invention that would transform navigation forever. But their compass was more than a simple directional tool. It was a cosmic instrument that connected the navigator to the fundamental forces of the universe. The Chinese believed that the magnetic needle was responding to the influence of the celestial dragon of the north, one of 4 mythical creatures that guarded the cardinal directions. The compass was not merely pointing north, it was aligning itself with the cosmic order that governed all things. Chinese navigators developed the most sophisticated star maps of the ancient world, creating detailed charts that showed not only the positions of individual stars, but also their relationships to the seasonal cycles and the movements of the planets. These maps were based on the Chinese system of lunar mansions, which divided the sky into 28 sections corresponding to the lunar month. Each mansion was associated with specific stars, mythological figures, and seasonal activities, creating a cosmic calendar that guided both navigation and daily life. The Chinese understanding of navigation was intimately connected to their concept of feng shui, the art of harmonizing human activity with the natural forces of the landscape. Chinese navigators believed that successful voyages required not only technical skill, but also spiritual harmony with the cosmos. They would consult the stars not only for directional guidance, but also to determine the most auspicious times for beginning a voyage, the proper rituals to ensure safe passage, and the spiritual preparations necessary for crossing the dangerous waters that separated the known world from the realm of dragons and monsters. The great Chinese Admiral Zheng He, who led 7 massive voyages across the Indian Ocean in the early 15th century, exemplified the sophistication of Chinese celestial navigation. His treasure fleets included ships over 400 feet long, carrying crews of thousands of sailors, soldiers, merchants, and scholars. These expeditions reached as far as East Africa, demonstrating a level of navigational skill that would not be matched by European explorers for another century. His navigators used a combination of traditional Chinese astronomical knowledge and techniques learned from Arab and Indian navigators. They carried star charts that showed the positions of key navigational stars, compass readings for different routes, and detailed sailing directions that included information about currents, winds, and the locations of safe harbors. Their navigational records, preserved in Chinese archives, provide remarkable insights into the sophistication of medieval Chinese navigation. The Chinese developed unique techniques for determining direction and position that were based on their understanding of the Earth's magnetic field and its relationship to celestial phenomena. They knew that the magnetic compass did not point to true north, but to magnetic north, and they developed methods for calculating the difference between magnetic and celestial north based on their location and the time of year. This knowledge allowed them to use the compass in conjunction with stellar observations to achieve remarkable navigational accuracy. Chinese navigators also possessed a sophisticated understanding of the relationship between celestial mechanics and terrestrial phenomena. They knew that the tides were caused by the gravitational pull of the moon and sun, and they developed detailed tide tables that predicted the times and heights of high and low tides for ports throughout the Chinese coast. They understood that the strength of the tides varied with the lunar phases, and they used this knowledge to time their arrivals and departures from shallow harbors. The Chinese tradition of celestial navigation was closely connected to their calendar system, which was based on complex astronomical calculations. The Chinese calendar combines solar and lunar elements, requiring precise observations of the sun, moon, and planets to maintain accuracy. Chinese navigators were therefore also astronomers, capable of predicting eclipses, planetary conjunctions, and other celestial events that might affect their voyages. The Chinese also developed sophisticated weather prediction techniques based on astronomical observations. They understood that certain star positions coincided with seasonal weather patterns, and they used this knowledge to predict the onset of monsoons, typhoons, and other weather phenomena that could affect navigation. They knew that the appearance of certain stars near the horizon could indicate approaching storms, and they developed detailed correlations between celestial events and weather patterns. The decline of Chinese navigation began in the mid-15th century, when the Ming dynasty turned inward and abandoned the great oceanic expeditions. The Confucian scholars who came to dominate Chinese policy viewed overseas exploration as a waste of resources that could be better spent on domestic affairs. The navigational knowledge that had made the treasure fleets possible was gradually forgotten, as China chose to focus on its vast continental empire rather than the endless possibilities of the sea. The knowledge of Chinese celestial navigation was preserved in various forms: official government records, private navigational manuals, and the oral traditions of fishing communities along the Chinese coast. Some of this knowledge was transmitted to other cultures through trade and cultural exchange, but much of it was lost when China withdrew from active participation in oceanic exploration. The sophisticated star charts, compass techniques, and astronomical calculations that had made Chinese navigation so successful became historical curiosities, studied by scholars but no longer used by practical navigators. As the age of exploration gave way to the age of empire, and as mechanical instruments began to replace human intuition, the ancient arts of celestial navigation entered a long twilight from which they would never fully emerge. The knowledge that had been passed down through generations of star watchers, accumulated over millennia of patient observation and practical experience, began to fade like morning mist before the rising sun of technological progress. The invention of the marine chronometer in the 18th century marked a turning point in the history of navigation. For the first time, navigators could determine their longitude with precision by comparing local time with the time at a known reference point. The chronometer eliminated the need for the complex lunar distance calculations that had been the hallmark of skilled navigators for centuries. What had once required years of training and a deep understanding of celestial mechanics could now be accomplished with a simple time comparison. The decline of traditional navigation knowledge was not immediate or uniform. In many parts of the world, particularly in regions where European influence was still limited, traditional navigators continued to use the ancient techniques that had served their ancestors for generations. Polynesian navigators in the remote Pacific continued to sail by the stars. Arab navigators in the Indian Ocean still used the Kamal and astrolabe, and Chinese fishing fleets continued to rely on traditional compass techniques and star knowledge. But the pressure of modernization was relentless. As European colonial powers extended their control over the world's oceans, they imposed their own navigational systems and training methods. Traditional navigators found themselves marginalized, their knowledge dismissed as primitive superstition by administrators who had never experienced the profound connection between human consciousness and cosmic order that lay at the heart of traditional navigation. The process of knowledge loss was accelerated by the disruption of traditional apprenticeship systems. In Polynesia, the conversion to Christianity often involved the suppression of traditional practices that were seen as pagan. Young people were encouraged to abandon the old ways and embrace modern education, which had no place for the ancient arts of star reading and wave piloting. The master navigators, growing old with no successors, took their knowledge with them to the grave. In the Islamic world, the decline of traditional navigation was hastened by political instability and economic disruption. The Ottoman Empire, which had preserved much of the classical Islamic knowledge, was in decline, and the traditional madrasas, where navigational knowledge was taught, were being replaced by Western-style schools. The ancient texts on navigation and astronomy were neglected, gathering dust in forgotten libraries, while their contents slowly became incomprehensible to new generations of scholars. The Chinese withdrawal from oceanic navigation had already begun in the 15th century, but the process was completed during the Qing dynasty, when China's maritime activities were further restricted by imperial decree. The knowledge that had made the treasure fleets possible was systematically suppressed, and the detailed navigational records were either destroyed or hidden away in imperial archives. The fishing communities that had preserved some of the traditional knowledge found themselves increasingly isolated as modern transportation and communication systems bypassed their traditional ways of life. The loss of traditional navigational knowledge was not merely a matter of technical skills becoming obsolete. These ancient systems represented entire ways of understanding the relationship between human beings and the cosmos. They embodied philosophical and spiritual traditions that viewed navigation not as a mechanical process, but as a form of communion with the natural world. The navigator was not merely a technician, but a priest of the cosmic order, capable of reading the subtle signs written in the sky and sea. As the old knowledge faded, something essential was lost from human culture: the deep connection between human consciousness and cosmic rhythms, which had been maintained for thousands of years through the practice of celestial navigation, was severed. Modern navigators, relying on electronic instruments and satellite signals, no longer needed to develop the heightened awareness and intuitive understanding that had characterized their predecessors. The sky became a distant backdrop rather than an intimate companion in the journey across the waters. The world wars of the 20th century completed the destruction of traditional navigation knowledge, the massive disruption of traditional communities, the death of countless skilled practitioners, and the urgent need for rapid training in modern navigation techniques left no time for preserving the ancient arts. Young navigators were taught to use radar, radio beacons, and electronic navigation systems, with no instruction in the traditional methods that had served humanity for millennia. By the middle of the 20th century, traditional celestial navigation had largely disappeared from practical use. The few remaining practitioners were elderly individuals living in remote communities, often unaware that their knowledge was precious and irreplaceable. Anthropologists and historians began to realize what was being lost, but their efforts to document and preserve traditional navigation knowledge were often too little, too late. When this knowledge was lost, humanity became, in a sense, partially blind to the natural world. People continued to live on a planet that orbited a star in a galaxy full of stars. But they lost much of their ability to consciously participate in the cosmic processes of which they were a part. They became like musicians trying to play in an orchestra without being able to hear the other instruments, still capable of making music, but no longer able to achieve the harmony that comes from conscious coordination with larger patterns. The loss was not total, of course. Some astronomical knowledge survived in various forms. Islamic scholars preserved and extended much Greek astronomical learning. Chinese astronomers maintained their own ancient traditions with remarkable continuity. Indigenous peoples around the world kept alive oral traditions that contained sophisticated astronomical information. But the particular synthesis that the ancient star priests had achieved, the integration of astronomical observation with religious practice, medical knowledge, agricultural wisdom, and social organization, was largely broken apart. What remained were fragments, calendar systems that worked, but whose underlying logic was no longer understood. Navigation techniques that functioned, but whose astronomical basis had been forgotten. Architectural monuments whose celestial alignments were still precise, but whose purpose had become mysterious. It was as if a great symphony had been scattered into individual notes, each still audible, but no longer part of a coherent musical structure. The star priests had also served as repositories of cultural memory in ways that went beyond their astronomical functions. They were often the keepers of historical records, the custodians of tribal genealogies, the preservers of traditional stories that encoded important information about past events and natural phenomena. When they disappeared, communities lost not just their astronomical expertise, but also their institutional memory. This created a kind of cultural amnesia that made societies more vulnerable to repeating past mistakes. Without the long-term perspective that astronomical observation had provided, people became more focused on immediate concerns and less capable of recognizing slowly developing patterns that might require adaptive responses. They lost what might be called cosmic consciousness, the awareness that human activities take place within larger contexts that operate on scales much longer than individual lifetimes. Yet, even as the living tradition of the star priests faded into silence, the monuments they had created continued to speak, though in a language that fewer and fewer people could understand. Across the world, ancient astronomical structures stood like silent teachers, their stone alignments still accurately marking celestial events, even as the knowledge of how to interpret them died away with their builders. Stonehenge continued to frame the midsummer sunrise exactly as its creators had intended thousands of years earlier. The Great Pyramids of Giza maintained their precise astronomical orientations, their passages still channeling starlight toward the chambers where had once been laid to rest in alignment with eternal constellations. The stone circles of Scotland, Ireland, and Wales kept their patient vigil, marking moon phases and stellar positions with mechanical precision that required no human intervention to maintain. These monuments became puzzles for later generations, mysterious achievements that seemed to require knowledge and capabilities that supposedly primitive peoples could not have possessed. Medieval travelers who encountered them often attributed their construction to giants or supernatural forces, unable to imagine that their ancestors had possessed astronomical knowledge sophisticated enough to plan and execute such precise celestial alignments that the irony was profound. The very people who were losing their connection to astronomical wisdom were living among monuments that demonstrated the extraordinary astronomical achievements of their predecessors. They walked past stone circles without realizing they were complex astronomical instruments. They marveled at the engineering of ancient pyramids without recognizing that their builders had been master astronomers as well as master architects. In some cases, local traditions preserved fragments of the original meaning, though usually in corrupted or simplified forms. Folklore spoke of stones that marked special days, of buildings that captured light in mysterious ways, of ancient peoples who had possessed magical knowledge of the stars. These stories were often dismissed as superstition by educated people who had lost the keys to understand the sophisticated astronomical science they represented. The Gothic cathedrals of medieval Europe, built centuries after the star priests had been silenced, sometimes inadvertently echoed the astronomical principles of their ancient predecessors. Cathedral builders, concerned with creating spaces that would inspire religious awe, often aligned their structures with celestial directions and incorporated solar lighting effects that created dramatic illumination on important holy days. They did this primarily for theological and aesthetic reasons, but the results sometimes resembled the astronomical temples of earlier eras. However, the cathedral builders generally lacked the deeper astronomical knowledge that had guided their ancient predecessors. Their alignments were usually simpler, based on basic solar directions, rather than the complex stellar and planetary positions that had been incorporated into earlier monuments. They created impressive effects, but they were working from incomplete understanding of the astronomical principles involved. In the Americas, the situation was particularly poignant. When European explorers and conquistadors encountered the astronomical monuments of the Maya, Aztec, and Inca civilizations, they were confronted with evidence of astronomical sophistication that challenged their assumptions about the capabilities of indigenous peoples. The Mayan calendar system was actually more accurate than the European calendar in use at the time of contact. Inca road systems and agricultural terraces showed clear evidence of astronomical planning that European engineers struggled to understand. But instead of recognizing these achievements as evidence of sophisticated astronomical knowledge, European colonizers often explained them in ways that diminished indigenous accomplishments. They attributed astronomical monuments to lost European settlers, or to divine intervention, or to mysterious vanished civilizations that must have been more advanced than the indigenous peoples they encountered. This interpretation allowed them to maintain their sense of cultural superiority while acknowledging the obvious astronomical sophistication of the monuments they found. The destruction that followed European contact eliminated many of the last practitioners of ancient astronomical traditions in the Americas. Indigenous astronomers who might have been able to explain the meaning of ancient monuments were killed by disease or violence, or forced to abandon their traditional practices in favor of European customs. Their knowledge died with them, leaving behind monuments whose astronomical significance would take modern archaeologists centuries to decode. As the medieval period deepened across Europe, the silence around ancient astronomical wisdom became so complete that it began to seem normal. Generations grew up knowing only the simplified astronomy taught in monastery schools, unaware that their ancestors had once possessed knowledge that would have seemed miraculous by medieval standards. The night sky, which had once been as familiar and readable as a well-worn book, became a distant mystery, beautiful but largely irrelevant to daily life. This astronomical amnesia created a peculiar situation. people living on a planet whose movements through space affected every aspect of their lives, but largely unconscious of the cosmic context in which those lives unfolded. They planted crops and harvested them, but without the sophisticated understanding of seasonal cycles that had guided their predecessors. They traveled by land and sea, but without the stellar navigation techniques that had once allowed precise, long-distance journeys. The result was a kind of cosmic isolation that would have been incomprehensible to the ancient star priests. Medieval people lived as if the Earth were the entire universe, with the sky serving merely as a distant ceiling, rather than as the infinite space through which their planet moved, in complex patterns that affected everything, from weather to biological cycles. This isolation was not merely intellectual, it was also spiritual and emotional. The star priests had seen human life as part of a vast cosmic dance, finding meaning and purpose in conscious participation in celestial rhythms. Medieval people, largely cut off from this cosmic perspective, had to find meaning in more limited contexts, in their relationships with family and community, in their service to earthly lords, in their hopes for individual salvation. These were not inadequate sources of meaning, but they lacked the grand perspective that astronomical knowledge had once provided. People could no longer situate their personal struggles within the context of cosmic cycles that connected them to the fundamental processes of the universe. They had become like actors performing on a stage without being able to see the larger play of which their individual roles were a part. The practical consequences of this astronomical ignorance were often severe. Without accurate long-term weather prediction, farmers faced more frequent crop failures. Without precise navigation, sea voyages became more dangerous and uncertain. Without sophisticated medical astronomy, healing practices became less effective and more hit or miss. But perhaps the most profound loss was harder to measure. The loss of wonder, of conscious connection to something larger than individual human concerns, of the sense that human life was part of a meaningful cosmic story, rather than an isolated accident in an indifferent universe. The star priests had provided not just practical services, but also a worldview that situated human existence within a context of cosmic purpose and meaning. This worldview began to seem not just lost, but impossible to recover. The knowledge that had been accumulated over millennia had been so thoroughly destroyed or forgotten that it began to seem like it had never existed at all. Medieval scholars, encountering references to ancient astronomical achievements in old texts, sometimes dismissed them as exaggerations or misunderstandings. Unable to believe that their predecessors had actually possessed such sophisticated knowledge, the silence of the star priests became so complete that it began to reshape how people thought about the relationship between knowledge and time. Instead of seeing themselves as inheritors of ancient wisdom who might build upon foundations laid by their predecessors, medieval people began to see themselves as pioneers working from scratch to understand a universe that had never been properly studied before. This perspective would eventually prove both liberating and limiting. It freed later astronomers from having to conform to ancient authorities, allowing them to develop new approaches and make discoveries that might not have been possible within traditional frameworks. But it also meant that they had to rediscover, often painfully and slowly, insights that had been well understood by their ancient predecessors. The star priests entered a kind of historical sleep, their voices falling silent, their knowledge disappearing into the darkness like stars hidden by clouds. But like stars obscured by passing weather, they remained present even when invisible, waiting for conditions that might allow their light to be seen again. Their monuments continued to mark celestial events with unfailing precision, and their wisdom lay buried in scattered fragments that would eventually be discovered by people patient enough to listen to what the stones and the surviving texts were trying to say. The silence would not last forever, but it would last long enough that when ancient astronomical wisdom finally began to be recovered, it would seem like a revelation rather than a restoration, like the discovery of entirely new knowledge, rather than the recovery of wisdom that had once been common understanding among those who watched the sky with reverent attention and careful minds. The silence that had claimed the star priests would not last forever. In the quiet chambers of universities and beneath the patient gaze of telescopes, a new breed of seekers emerged, archaeoastronomers. They called themselves bridge builders between the ancient and the eternal. They came with instruments that would have seemed like magic to the temple builders of old, yet their hearts carried the same wonder that had driven humanity to first lift its eyes toward the wheeling stars. Dr. Sarah Chen stood in the pre-dawn darkness at Stonehenge, her breath forming small clouds in the crisp English air. The massive stones loomed around her like sleeping giants, their surfaces worn smooth by millennia of wind and rain. In her hands, she held a device that could measure celestial alignments to within fractions of degrees, precision that would have astounded the ancient builders, yet served the same fundamental purpose: to understand humanity's place beneath the vast cosmic dome. "Every stone is a star," she whispered to her colleagues, echoing words that Gerald Hawkins had spoken decades earlier when he first proposed that Stonehenge was an ancient computer, calculating eclipses and tracking celestial cycles with breathtaking accuracy. The monument was not merely a temple or a tomb, but a cosmic calendar carved in stone. Its purpose as profound as it was practical. The revelation had come slowly, painstakingly, as researchers mapped the alignments with modern precision. The heel stone marked the summer solstice sunrise with uncanny accuracy. The avenue pointed toward the midsummer dawn, while the trilithons framed the midwinter sunset. Most remarkably, the complex arrangement of stones could predict lunar eclipses centuries in advance, functioning as a megalithic computer that calculated the dance of shadow and light across the face of the moon. Yet Stonehenge was only the beginning. Across the world, archaeoastronomers were discovering that nearly every ancient monument held celestial secrets. The pyramids of Giza aligned with Orion's belt, their shafts pointing toward specific stars that carried the pharaoh's soul to the afterlife. The temples of Angkor, Wat, mirrored the constellation Draco, their causeway stretching toward the spring equinox like a stone finger pointing toward cosmic renewal. In Peru, Maria Reich had spent her life mapping the Nazca lines, those mysterious geoglyphs etched into the desert floor by hands that had been dust for over 1,000 years. What had seemed like random lines and figures revealed themselves as a vast astronomical calendar. Spider and hummingbird and monkey all pointing toward significant celestial events. The lines themselves served as horizon calendars, marking the rise and set of crucial stars and constellations. They were not primitive, Reich would say, her voice carrying decades of patient observation. They knew the sky better than we do. They lived beneath it every night, read it like a book, found in it not just navigation and timing, but meaning itself. Her weathered hands traced the patterns on her charts, connecting the ancient lines to star charts that revealed a sophistication that humbled modern observers. The more the archaeoastronomers looked, the more they found. Newgrange in Ireland, older than Stonehenge, older than the pyramids, designed so that sunlight would penetrate its chamber only on the winter solstice. illuminating the darkness at the year's turning point. The medicine wheels of the Great Plains, stone circles that tracked the rising of Aldebaran, and the heliacal rising of Rigel and Sirius. Each discovery reinforced the same profound truth. Ancient peoples had possessed an intimate knowledge of the sky that modern civilization had largely forgotten. At Chichen Itza, Dr. Anthony Aveni stood before the Great Pyramid of Kukulkan as the spring equinox sun cast shadows down its steps, creating the illusion of a serpent descending the stone structure. The Maya had engineered this precise effect, aligning their pyramids so that twice each year, at the moments of perfect balance between day and night, their feathered serpent god would appear to slither down from heaven to earth. It was architecture as astronomy, building as prayer, stone as star map. They understood something we're only beginning to rediscover. Aveni explained to his students, his voice carrying the excitement of someone who had spent his career unlocking cosmic puzzles. They didn't separate the sacred from the scientific, the earthly from the celestial. Their astronomy was their religion, their mathematics was their mythology. They built their cities as mirrors of the sky, living within cosmic order rather than apart from it. The rediscovery was not without its controversies. Traditional archaeologists, trained to see monuments in terms of political power and social hierarchy, initially resisted the astronomical interpretations. How could ancient peoples, without writing systems or sophisticated mathematics, have achieved such precision? The question revealed more about modern assumptions than ancient capabilities, betraying a deep-seated belief that technological progress moved only in one direction. That knowledge accumulated rather than rose and fell, but the evidence mounted, alignment by alignment, correlation by correlation. At Abu Simbel, Ramses II's great temple was positioned so that twice each year, sunlight would penetrate the sanctuary and illuminate the statues of the pharaoh and the gods precisely on his birthday and his coronation day. The precision was not accidental. It was intentional, calculated, achieved through a sophisticated understanding of solar mechanics that required generations of careful observation. In Cambodia, the temples of Angkor revealed themselves as a vast astronomical map when viewed from above. The arrangement of structures corresponded to the constellation Draco during the spring equinox of 1150 CE, the temples serving as earthly mirrors of the celestial realm. The Khmer Empire had built their capital as a reflection of the cosmos, their king serving as the earthly representative of the gods who dwelt among the stars. The pattern repeated across cultures and continents. The ancestral Pueblans of Mesa Verde aligned their cliff dwellings with solstices and equinoxes, their calendar petroglyphs tracking the sun's annual journey with mathematical precision. The Aboriginal Australians encoded star maps in their rock, art, and song lines, creating a continent-spanning network of astronomical knowledge that stretched back 60,000 years. The Polynesians navigated vast ocean distances using star compasses memorized in chant and dance, their knowledge systems as sophisticated as any modern navigation technology. Each discovery added to a growing understanding. Humanity's relationship with the cosmos was not a recent development, but an ancient inheritance, a way of knowing that had been refined over millennia before being largely forgotten in the rush toward industrial modernity. The star knowledge that had once guided civilizations across the globe was not primitive superstition, but sophisticated science, wrapped in mythological language that preserved essential information across generations of oral transmission. As the 21st century dawned, Technology that would have seemed miraculous to ancient astronomers began to unlock secrets that had been hidden for millennia. Computer programs could now simulate the ancient sky with perfect accuracy, showing exactly what stars had been visible from any location at any time in history. Satellite imagery revealed patterns in landscapes that ground-level observers had never seen. Ground-penetrating radar discovered buried structures that had been lost for centuries. The Giza Pyramid Complex yielded its secrets to cosmic raymography, a technique that used particles from deep space to peer inside stone structures without disturbing them. Hidden chambers were discovered within the Great Pyramid, spaces that had been sealed since the pyramid's construction over 4,000 years ago. What lay within those chambers remained a mystery, but their very existence proved that the ancient builders had incorporated levels of sophistication that archaeologists were only beginning to understand. In Turkey, satellite archaeology revealed the true extent of Göbekli Tepe, the mysterious temple complex that predated Stonehenge by 6,000 years. What had seemed like an isolated site proved to be part of a vast network of similar structures, all aligned with stellar phenomena, all built by hunter-gatherer societies that were supposedly too primitive for such monumental architecture. The discovery challenged fundamental assumptions about the development of civilization, suggesting that astronomical knowledge had driven cultural complexity rather than following from it. Digital reconstructions allowed researchers to walk through ancient observatories as they had existed at their peak. The software painted virtual skies over reconstructed buildings, showing how shadows would have fallen across calibrated surfaces, how light would have penetrated specifically designed openings, how the architecture itself had functioned as a massive instrument for reading the cosmos. Chanquillo in Peru revealed itself as the world's oldest known solar observatory, its 13 towers marking the sun's position throughout the year with extraordinary precision. The international collaboration that emerged around these discoveries would have pleased the ancient astronomers, who had often worked across cultural boundaries to share their observations. Modern researchers from dozens of countries contributed to a growing database of archaeoastronomical sites, their findings revealing patterns that transcended individual civilizations, whether in Egypt or Mexico, Cambodia or Britain. Ancient peoples had built monuments that aligned with the same celestial phenomena, suggesting either widespread cultural contact or, more intriguingly, shared human responses to the cosmic environment. Dr. Eurita Holbrook, working at the intersection of African astronomy and archaeoastronomy, uncovered evidence of sophisticated sky knowledge among cultures that had been dismissed by colonial observers as primitive. The Dogon people of Mali had possessed detailed knowledge of Sirius B, a white dwarf companion star invisible to the naked eye, centuries before European astronomers discovered it with telescopes. Their astronomical traditions, preserved in oral literature and ritual practice, revealed a depth of stellar knowledge that challenged assumptions about the relationship between technology and astronomical observation. Knowledge systems don't require telescopes, Holbrook explained to audiences, hungry to understand how ancient peoples had achieved such precision without modern instruments. They require patience, persistence, and cultural institutions that value careful observation across generations. The ancient astronomers didn't need to see Sirius B directly. They could infer its existence from the behavior of Sirius A, from the subtle perturbations in its motion that revealed the gravitational influence of an unseen companion. In India, researchers discovered that ancient texts contained remarkably accurate calculations of planetary periods and eclipse cycles. The Surya Siddhanta, composed over 1500 years ago, calculated the length of a year to within minutes of modern measurements. The text described techniques for predicting eclipses centuries in advance, mathematical methods that rivaled contemporary computational approaches. The knowledge had been there all along, preserved in Sanskrit verses that had been chanted and copied by generations of scholar priests. The Antikythera mechanism, the bronze marvel pulled from the Mediterranean depths, finally revealed its secrets. Through high-resolution X-ray tomography, the device proved to be even more sophisticated than initially suspected, containing gear trains that calculated not only solar and lunar cycles, but the movements of all known planets. It was, in essence, the world's first analog computer, built to model the cosmos in bronze and brass over 2,000 years before the electronic age. As the mechanism's inscriptions were decoded, they revealed a cosmological understanding that bridged Greek philosophical speculation with Babylonian mathematical precision. The device had been designed not merely to predict eclipses or track planetary positions, but to demonstrate the eternal harmony of celestial motions, the music of the spheres made manifest in turning gears. It was science and art combined, mathematics made beautiful, astronomy rendered tangible. The rediscovery process revealed as much about modern blind spots as about ancient achievements. Why had it taken so long to recognize the astronomical sophistication of ancient cultures? The answer lay partly in cultural prejudices that assumed technological progress followed a linear path, that ancient peoples were necessarily less capable than modern ones, but it also reflected the modern separation of scientific and religious thinking, a division that would have been incomprehensible to ancient astronomers who saw no contradiction between mathematical precision and sacred meaning. Contemporary astronomers began to appreciate skills they had lost in their rush toward technological solutions. The ability to navigate by stars, to predict weather through cloud formations, to track time through natural phenomena, these were capabilities that had been essential to human survival for millennia but had atrophied in modern urban environments. Indigenous communities still maintaining traditional knowledge systems became valuable teachers, their elders carrying information that universities had never preserved. In Australia, Aboriginal astronomers worked with Western researchers to document songlines that encoded star maps stretching across the continent. The songs, passed down through tens of thousands of years of oral tradition, contained navigational information, seasonal indicators, and cultural knowledge that connected human communities to cosmic cycles. The collaboration revealed that the oldest continuous culture on Earth had also maintained the oldest continuous astronomical tradition, a living link to humanity's deepest past. The Hawaiian Polynesian Voyaging Society reconstructed traditional navigation techniques that had guided ancient voyagers across thousands of miles of open ocean using only star knowledge, wave patterns, and natural signs. Master navigator Nanoa Thompson learned the traditional star compass from elderly practitioners and used it to guide modern replicas of ancient voyaging canoes between Pacific islands. The successful journeys proved that Polynesian expansion had been based on sophisticated navigational science, not accidental drift. The ocean is a laboratory, Thompson explained, his weathered hands gesturing toward the endless Pacific horizon. The ancients read it like a book: wave patterns, bird behavior, cloud formations, the taste of water, the color of the sky. But, most importantly, they read the stars. The star compass was their GPS, memorized in chant and story, passed down through generations of navigator priests who understood that finding your way across the ocean meant finding your place in the cosmos. even as modern technology revealed the sophistication of ancient astronomy. Researchers began to understand that the most important discoveries were not about instruments or calculations, but about ways of knowing that integrated human consciousness with cosmic awareness. The ancient astronomers had not merely observed the sky. They had lived within it, understanding themselves as participants in celestial processes, rather than external observers of them. Dr. Stanislav Volkov, a Russian physicist turned consciousness researcher, spent years studying traditional shamanic practices in Siberia, seeking to understand how indigenous cultures had developed such precise astronomical knowledge without written records or mathematical notation. What he discovered challenged fundamental assumptions about the nature of knowledge itself. The shamans, he learned, had developed techniques for expanding awareness that allowed them to perceive patterns invisible to ordinary consciousness. They don't separate the observer from the observed, Volkov explained to skeptical colleagues. At academic conferences, his presentations generating controversy and fascination in equal measure. Through ritual practices, meditation, and altered states of consciousness, they enter into direct relationship with cosmic cycles. They don't just observe the stars, they participate in stellar consciousness. Their knowledge comes not from external measurement, but from internal attunement. The implications were profound and disturbing for Western scientific methodology, which had built its authority on the separation between subjective experience and objective measurement. Yet the precision of traditional astronomical knowledge suggested that consciousness-based approaches might access information unavailable to purely external observation. The question was not whether such knowledge was accurate. The evidence proved it was, but how it was possible within conventional scientific frameworks in the high Andes. The Quero people of Peru maintained astronomical traditions that integrated practical observation with visionary experience. Their Ultimai Seoks, master shamans, who served as bridges between human and cosmic consciousness, could predict weather patterns months in advance by reading subtle signs in the behavior of the Pleiades. They understood the mountain peaks around them as astronomical instruments, their profiles marking seasonal changes with more accuracy than mechanical calendars. Don Carlos Morales, an elderly Altamesok, explained the practice to anthropologist Dr. Elizabeth Jenkins, with words that challenged Western distinctions between science and spirituality. "The stars are not distant lights," he said, his gnarled hands tracing patterns in the mountain air. "They are living beings, ancestors who guide us through the seasons of earth and sky. To know their movements, you must know their hearts. To predict their behavior, you must understand their purposes. This requires not just watching, but listening, not just measuring, but merging." Similar approaches appeared in cultures worldwide. Australian Aboriginal Dreamtime narratives encoded astronomical information in mythological stories that served as mnemonic devices for precise celestial knowledge. The emu in the sky, formed by dark dust lanes in the Milky Way, told initiated hunters when emu eggs would be ready for gathering. The seven sisters of the Pleiades carried seasonal information crucial for survival in the harsh continent, their story songs preserving both practical knowledge and sacred meaning. Celtic Druids had maintained an astronomical tradition that integrated star knowledge with herbal medicine, understanding plant and animal cycles as reflections of celestial rhythms. The timing of harvest, the preparation of healing medicines, the performance of ritual ceremonies, all were coordinated with astronomical events that connected earthly activities to cosmic harmonies. The tradition had been nearly destroyed by Roman conquest and Christian conversion, but fragments survived in folk practices and archaeological evidence. Modern researchers, attempting to understand these integrated knowledge systems, found themselves confronting limitations of their own. Methodological assumptions. How could one study consciousness-based astronomy using tools designed for external measurement? How could laboratory conditions replicate practices that required years of training and cultural initiation? The questions pushed at the boundaries of acceptable scientific inquiry, suggesting that some forms of knowledge might be inherently resistant to reductionist analysis. Dr. Marilyn Schlitz, working at the intersection of consciousness research and anthropology, spent decades documenting instances where traditional astronomers demonstrated knowledge that seemed to exceed what external observation could provide. Tibetan monks who could predict weather patterns with remarkable accuracy, despite living in monasteries with limited sky access. Mayan daykeepers who maintained calendar calculations of stunning precision through purely oral traditions. Aboriginal elders who could navigate vast territories using stellar knowledge memorized through song. We're dealing with different Schlitz explained in her groundbreaking paper on indigenous knowledge systems. Different ways of knowing that don't fit into Western scientific categories. These traditions suggest that consciousness and cosmos might be more intimately connected than our materialist paradigms allow. Perhaps the ancients knew something about the nature of mind and universe that we've forgotten in our focus on external instrumentation. The suggestion was radical enough to generate fierce academic debate. Could consciousness really access information about cosmic cycles through non-sensory means? The evidence was ambiguous but persistent, appearing in too many cultures and contexts to dismiss as coincidence or wishful thinking. Traditional astronomers consistently demonstrated knowledge that exceeded what their observational tools should have provided, suggesting either remarkably sophisticated inference techniques or, more provocatively, direct consciousness interaction. Quantum physicists, familiar with the role of consciousness in determining physical phenomena, found the proposals less radical than their classical colleagues. If observation affected reality at the quantum level, perhaps consciousness played a larger role in cosmic processes than mechanistic astronomy acknowledged. The ancient integration of observer and observed might reflect deep truths about the nature of reality that modern science was only beginning to rediscover. Dr. Amit Goswami, a quantum physicist turned consciousness researcher, proposed that ancient astronomical knowledge systems might have operated through what he called quantum consciousness, direct awareness of quantum fields that connected mind to cosmos at the most fundamental level. The hypothesis was speculative, but provided a framework for understanding how consciousness-based observation might access information unavailable to purely mechanical measurement. The ancients may have been operating from a different understanding of consciousness itself, Goswami suggested in his controversial presentations. If consciousness is not produced by the brain, but rather channels universal awareness, then properly trained observers might access information fields that connect all cosmic phenomena. What we call astronomical knowledge might actually be cosmic consciousness, direct participation in the intelligence that organizes stellar and planetary movements. Whether or not such explanations proved acceptable to mainstream science, the evidence for traditional astronomical sophistication continued to accumulate. Indigenous knowledge keepers who had maintained their traditions, despite centuries of suppression, found themselves suddenly valuable to researchers struggling to understand how ancient peoples had achieved such precision. The wisdom keepers, long dismissed as primitive or irrelevant, emerged as guardians of knowledge systems that might hold keys to understanding consciousness cosmos, relationships that mechanistic science had never explored. As the 21st century progressed, humanity found itself in a curious position, technologically more advanced than any previous civilization, yet hungering for the cosmic connection that ancient peoples had taken for granted. Light pollution had stolen the stars from most human eyes. Urban environments had severed the connection between daily life and natural cycles. Digital screens had replaced the sky as the primary source of illumination and information, leaving most people ignorant of basic astronomical phenomena there. Ancestors had monitored with religious devotion. The rediscovery of ancient astronomical wisdom began to inspire a different kind of renaissance, not just academic understanding, but experiential reconnection. Dark sky preserves were established to protect remaining areas where the Milky Way could still be seen with the naked eye. Astronomy clubs organized star parties that taught basic observational skills. Planetariums created programs that simulated ancient skies, allowing modern visitors to experience the cosmic environment that had shaped human consciousness for millennia. At Atacama Desert Observatories, where some of the world's most sophisticated telescopes probed the deepest reaches of space, visiting researchers often found themselves overwhelmed by their first glimpse of truly dark skies. The experience was transformative, visceral, humbling in ways that classroom astronomy could never approximate. Under the star-drunk desert sky, surrounded by instruments that could detect galaxies billions of light-years away, many scientists reported a profound sense of returning to something essential that urban civilization had abandoned. Dr. Sandra Chen, an astrophysicist who had spent her career studying galactic evolution through computer models and telescope data, described her first night at Atacama as a homecoming she hadn't known she needed. I understood for the first time why ancient peoples built their temples aligned with stars. She wrote in her personal journal, "The sky wasn't just a source of information, for them it was their context, their reference point, their source of meaning. We've gained incredible precision in our measurements, but we've lost the felt sense of cosmic participation that made astronomy sacred rather than merely technical." Indigenous astronomers, finding themselves suddenly relevant to cutting-edge research, began sharing traditional knowledge that complemented and sometimes corrected modern observations. Native Hawaiian astronomers worked with Mauna Kea observatories to incorporate traditional star knowledge into contemporary research programs. Aboriginal Australians collaborated with radio astronomers to map the sky, using both traditional stories and modern instruments, creating hybrid knowledge systems that honored both ancient wisdom and contemporary science. The collaboration revealed unexpected connections between traditional knowledge and modern discoveries. Aboriginal stories about the behavior of certain stars correlated with recent findings about stellar variability. Polynesian navigation techniques used wave patterns that modern oceanographers were only beginning to understand. Traditional eclipse predictions, passed down through oral traditions for centuries, matched computer calculations with startling accuracy. But perhaps more importantly, the encounter with traditional astronomical knowledge began to transform how modern researchers understood their own work. The ancient integration of astronomy with agriculture, medicine, architecture, and spiritual practice suggested that the modern academic separation of disciplines might be artificial, even counterproductive. The cosmos, after all, was an integrated system. Perhaps understanding it required integrated approaches that ancient astronomers had practiced intuitively. Archaeoastronomy itself evolved beyond the mere cataloguing of alignments to become a bridge between scientific and humanistic understanding. Researchers began to appreciate that ancient monuments were not just calculating devices, but expressions of worldviews that understood human culture as embedded within cosmic order. The precision of astronomical alignments reflected not just mathematical sophistication, but philosophical commitments to living in harmony with universal rhythms. The International Astronomical Union, recognizing the cultural importance of traditional sky knowledge, established a working group on astronomy and world heritage that sought to preserve both dark skies and the cultural traditions that had grown up around them. The initiative acknowledged that astronomical heritage was not merely about protecting ancient monuments, but about maintaining living connections between human communities and cosmic environments. In schools around the world, educators began incorporating traditional astronomical knowledge into science curricula, not as historical curiosities, but as alternative approaches to understanding celestial phenomena. Students learned to navigate by stars, to track seasons through natural indicators, to understand their local environment as connected to cosmic cycles. The integration was not without controversy. Some traditionalists worried about diluting rigorous scientific education with non-Western approaches, but the results were encouraging. Children who learned astronomy through traditional stories and practical observation often developed deeper, intuitive understanding of celestial mechanics than those who encountered the cosmos only through textbooks and computer simulations. The ancient pedagogical techniques, which embedded factual information within meaningful narratives and direct experience, proved remarkably effective at creating lasting knowledge and genuine interest in astronomical phenomena. Environmental educators recognized connections between traditional astronomical knowledge and ecological awareness that had implications far beyond astronomy. Cultures that maintained close attention to celestial cycles also tended to live more sustainably within terrestrial ecosystems. The cosmic perspective that ancient astronomy fostered naturally led to understanding Earth as part of larger, natural systems, not as a resource to be exploited without reference to universal constraints. The climate crisis that dominated early 21st century concerns might have been prevented. Some researchers suggested if human societies had maintained the cosmic perspective that traditional astronomy provided, when human activities were understood as embedded within natural and cosmic cycles, unsustainable practices became obviously problematic. The ancient integration of astronomy with agriculture, for example, had prevented the kind of industrial farming that depleted soils and disrupted ecological balances. Space exploration itself began to incorporate lessons from traditional astronomical knowledge. NASA's Deep Space Network, which communicated with spacecraft throughout the solar system, recognized that indigenous traditions of long-distance navigation contained insights relevant to interplanetary travel. The psychological challenges of long-duration space missions might be addressed through traditional practices that helped maintain orientation and meaning across vast distances and timescales. Astronauts returning from space often reported experiences that echoed the transformative encounters with cosmic vastness that had shaped traditional astronomers. The overview effect, that profound shift in consciousness that came from seeing Earth from space, was perhaps similar to the expanded awareness that ancient sky watchers had, cultivated through patient observation and ritual practice. Both involve direct encounter with cosmic perspective that fundamentally altered understanding of human place and purpose. As private space exploration expanded, and the possibility of permanent human settlements beyond Earth became realistic, rather than theoretical, The question of how to maintain cultural and spiritual connection to cosmos became practical rather than merely philosophical. How would human communities sustain meaning and identity across the vast scales of space and time that interstellar exploration would require? Traditional astronomical knowledge systems, which had maintained cultural coherence across millennia of terrestrial change, might provide essential guidance for humanity's cosmic future. The most profound rediscovery was not about ancient techniques or forgotten calculations, but about a way of being in relationship with the cosmos that modern civilization had almost entirely abandoned. For the vast majority of human history, the sky had been alive, populated with ancestors and deities, pulsing with sacred meaning, intimately connected to every aspect of human existence. The stars were not distant nuclear furnaces, but companions, guides, sources of power and wisdom that shaped human destiny through their movements and configurations. This animistic understanding of the cosmos was not primitive superstition, but sophisticated ecological thinking that recognized the fundamental interconnectedness of all phenomena. Ancient astronomers understood what modern physics was beginning to rediscover: that consciousness and cosmos were not separate domains, but aspects of a single, living system. The precision of their observations and calculations emerged from this participatory relationship rather than despite it. Dr. Thomas Berry, the cultural historian and earth scholar who coined the phrase "the universe story," spent his later years exploring how ancient astronomical wisdom might guide humanity toward what he called the ecological age. The mechanistic worldview that had driven industrial civilization, he argued, was fundamentally unsustainable because it treated the cosmos as dead matter in motion rather than as a living system of which humanity was part. The ancient astronomers knew something we'd forgotten, Berry wrote in his final essays, his words carrying the weight of decades spent studying the intersection of spirituality and science. They understood that we don't live beneath the sky but within it, not separate from cosmic processes but embedded in them. Their astronomical practices were forms of communion, ways of attuning human consciousness to the larger intelligence that organizes galaxies and atoms alike. The implications extended far beyond astronomy to questions about the nature of intelligence itself. If the universe displayed organizational complexity that suggested purposeful design and modern cosmology increasingly pointed in that direction, then perhaps the ancient understanding of cosmic intelligence was more accurate than the mechanistic models that had dominated recent centuries. The precision of physical constants that allowed complex structures to emerge, the self-organizing properties of matter and energy, the evolution of consciousness from cosmic processes all suggested that the universe might indeed be alive in ways that ancient astronomers had recognized intuitively. Contemporary physicists working at the cutting edge of cosmological theory began to take seriously proposals that consciousness might be a fundamental feature of the universe rather than an accidental byproduct of complex chemistry. If consciousness was indeed cosmic rather than merely biological, then the ancient practices of consciousness-based astronomy might access real information about cosmic processes through means that mechanistic science had never explored. The research was controversial and necessarily speculative, but it opened possibilities for understanding how traditional astronomical knowledge systems had achieved such precision. Perhaps the shamans and priests who had maintained calendrical traditions for centuries had been accessing cosmic intelligence directly, participating in the awareness that organized stellar movements rather than merely observing them from the outside. Sacred sites around the world began to be understood not just as ancient observatories, but as places where the boundaries between human and cosmic consciousness became permeable. The stone circles and temple complexes, the medicine wheels and burial mounds, had been designed not just to track celestial movements, but to facilitate direct encounter with the intelligence that guided those movements. They were portals, rather than merely instruments, places of communion rather than simple calculation. Modern visitors to these sites sometimes reported experiences that suggested the ancient function might still be accessible. At Stonehenge during solstice celebrations, at Machu Picchu under the Southern Cross, at the Great Pyramid during stellar alignments, sensitive individuals described profound shifts in consciousness that provided direct insight into cosmic processes. The experiences were subjective and difficult to validate scientifically, but they were consistent enough to suggest that the sites retained some capacity to facilitate the expanded awareness that ancient astronomers had cultivated. The question of how to integrate such experiences with rigorous scientific methodology remained unresolved, but it was being taken seriously by researchers at the intersection of consciousness studies and cosmology. Perhaps the future of astronomy would require not just more sophisticated instruments, but also more sophisticated observers, human beings, trained to participate consciously in the cosmic processes they sought to understand. Indigenous communities, maintaining traditional astronomical practices, became valuable teachers for researchers interested in developing such capacities. The training was necessarily long-term and culturally embedded, requiring not just intellectual learning but transformation of consciousness that could take years or even decades to achieve. It was a form of scientific training that academic institutions were not equipped to provide. Yet it might be essential for accessing forms of cosmic knowledge that purely external observation could never reach. The collaboration between traditional knowledge keepers and contemporary researchers began to generate new forms of astronomical practice that integrated ancient wisdom with modern instruments. Radio telescopes were operated during traditional ceremonial times to detect whether cosmic electromagnetic phenomena correlated with indigenous predictions. Particle detectors were positioned at sacred sites to investigate whether consciousness media processes produced measurable physical effects. The research was necessarily exploratory and often inconclusive, but it opened new frontiers for investigating consciousness relationships. Perhaps most importantly, the encounter with traditional astronomical knowledge began to transform how modern people understood their relationship to the natural world. The cosmic perspective that ancient astronomy provided naturally led to ecological awareness, understanding human activities as embedded within natural and universal systems, rather than separate from them. The climate crisis, the extinction crisis, the crisis of meaning that characterized contemporary civilization, all might be addressed through recovering the sense of cosmic participation that traditional astronomy had fostered. Children growing up with access to dark skies and traditional star knowledge developed differently than their urban counterparts, showing greater capacity for systems thinking, longer attention spans, deeper sense of connection to natural processes. The ancient role of astronomy in human development as a source of wonder, meaning, and practical wisdom proved to be as relevant in the modern world as it had been in traditional societies. Educational programs that combined traditional astronomical knowledge with contemporary science produced graduates who thought more holistically about environmental and social challenges. They understood climate change not just as a technical problem requiring technological solutions, but as a symptom of disconnection from cosmic and natural systems that required fundamental changes in consciousness and culture. The integration was not without challenges. Traditional knowledge systems were often embedded in cultural contexts that resisted extraction and generalization. The precise astronomical knowledge that indigenous communities had maintained was inseparable from languages, ceremonies, and social structures that outsiders could not easily access or appropriate. The collaboration required deep respect, long-term commitment, and genuine partnership, rather than simple extraction of useful techniques. As the rediscovery of ancient astronomical wisdom continued, researchers began to recognize patterns that suggested human knowledge of the cosmos moved in great cycles rather than linear progression. Civilizations rose and fell. Knowledge was gained and lost. Astronomical understanding peaked and declined in rhythms that might themselves reflect cosmic processes operating on scales larger than individual human societies could comprehend. The Library of Alexandria had preserved astronomical knowledge from across the ancient world, its scholars synthesizing Babylonian mathematics with Egyptian star maps, Greek geometric models with Indian computational techniques. The destruction of the library had not been a single catastrophic event, but a gradual process of cultural transformation that prioritized religious dogma over empirical observation, political orthodoxy over scientific inquiry. The loss of astronomical knowledge had been part of a larger civilizational shift that chose certainty over wonder, control over mystery. Islamic astronomers had preserved and extended classical knowledge during the European Dark Ages. An observatory is maintaining traditions of mathematical astronomy that would eventually be transmitted back to Europe through centers like Toledo and Cordoba. The knowledge had never been entirely lost, but had migrated, transformed, adapted to new cultural contexts, while preserving essential insights about cosmic structure and process. The pattern suggested that astronomical knowledge was too important to human survival to be permanently lost. Even when civilizations collapsed and libraries burned, the essential insights found ways to survive in oral traditions, in architectural alignments, in calendrical practices maintained by communities that valued practical sky knowledge over theoretical abstractions. The wisdom moved like water, finding channels through cultural landscapes, disappearing underground when surface conditions were hostile, emerging again when circumstances allowed. Modern astronomy, despite its technological sophistication, was perhaps another phase in this eternal cycle of discovery and loss, understanding and forgetting. The instruments grew more powerful, the calculations more precise, but the fundamental questions remained the same. What is our place in the cosmos? How do cosmic processes influence terrestrial life? What can the sky teach us about meaning and purpose? The ancient answers to these questions had been embedded in cultural practices that sustained communities across generations. Modern answers, focused on technical precision rather than existential meaning, had produced extraordinary detailed knowledge about cosmic phenomena while leaving most people feeling alienated from the very cosmos they inhabited. The challenge was to integrate ancient wisdom with contemporary understanding in ways that addressed both technical and existential dimensions of astronomical knowledge. Some researchers began to explore whether the cyclical patterns of civilizational rise and decline might themselves reflect astronomical phenomena operating on scales that individual cultures could barely detect. Galactic cycles, precessional rhythms, solar variations, climate oscillations all might influence human societies in ways that were difficult to perceive from within historical timeframes, but might be obvious from cosmic perspectives. The Maya long count calendar, with its precise tracking of vast temporal cycles, suggested that ancient astronomers had been aware of processes operating on scales that modern civilization was only beginning to recognize. The calendar's emphasis on recurring patterns, rather than linear progression, reflected a sophisticated understanding of time as cyclical rather than directional, with periods of creation and destruction, growth and decay, knowledge and forgetting, following predictable rhythms.
If human consciousness was indeed embedded within cosmic processes, then the evolution of astronomical knowledge might follow patterns determined by forces larger than individual human choice or cultural development. Periods of cosmic awareness might alternate with periods of cosmic forgetting according to rhythms that reflected the breathing of the universe itself. The expansion and contraction of consciousness that paralleled the physical expansion and potential contraction of space-time. The current resurgence of interest in traditional astronomical knowledge might represent the beginning of a new cycle of cosmic awareness, driven by the convergence of technological capability with environmental crisis that forced recognition of humanity's embeddedness within natural and cosmic systems. The tools existed to investigate consciousness-cosmos relationships that previous generations could only explore through direct experience. The crisis existed to motivate investigation of alternative approaches to understanding human place and purpose. But the integration would require more than technical achievement or academic research. It would require transformation of consciousness that allowed modern people to experience the cosmos as living and meaningful rather than dead and mechanical. The ancient astronomical practices had been designed to facilitate such transformation, but they were embedded in cultural contexts that no longer existed. The challenge was to develop contemporary practices that achieved similar results while honoring both ancient wisdom and modern understanding. Meditation practices that combined traditional astronomical observation with modern knowledge of cosmic evolution began to emerge in communities around the world. Participants learned to track celestial movements through direct observation, while simultaneously understanding those movements in terms of stellar evolution, galactic rotation, cosmic expansion. The integration produced experiences of cosmic awareness that were both scientifically informed and existentially meaningful. Educational programs that taught children to navigate by stars, to track seasons through natural indicators, to understand local ecosystems as connected to cosmic cycles, produced young people who thought differently about environmental and social challenges. They understood climate change not just as a technical problem, but as a symptom of disconnection from natural systems that required fundamental changes in consciousness and culture. Space exploration programs began to incorporate practices derived from traditional astronomical knowledge, recognizing that the psychological and spiritual challenges of long duration space travel might require approaches that ancient astronomers had developed for maintaining orientation and meaning across vast scales of space and time. The overview effect that astronauts experienced might be similar to the expanded awareness that traditional skywatchers had cultivated through patient observation and ritual practice. The convergence suggested that humanity might be approaching a new phase in its relationship with the cosmos, one that integrated the precision of modern instruments with the wisdom of ancient practices. The objectivity of scientific method with the subjectivity of consciousness-based observation. The integration would not be easy or automatic, but it might be necessary for addressing the challenges that would define humanity's cosmic future. Whether humanity would successfully navigate this integration, or whether the current phase of technological civilization would follow previous patterns of rise and decline, remained an open question. But the rediscovery of ancient astronomical wisdom provided resources for understanding both the challenge and potential approaches to addressing it. The stars that had guided previous generations continued to shine, their light carrying information about both cosmic history and cosmic destiny that was available to any consciousness capable of receiving it. In the end, perhaps the most important rediscovery was not about ancient techniques or forgotten calculations, but about the possibility of living in conscious relationship with the cosmos rather than alienated from it. The ancient astronomers had known that human consciousness and cosmic processes were not separate phenomena but aspects of a single, unfolding reality. Their observations and calculations had emerged from this participatory understanding rather than despite it, and their precision had reflected not just technical skill, but spiritual attunement to the intelligence that organized galaxies and atoms alike. The silence that had fallen upon the star priests was not permanent. in observatories and laboratories, in sacred sites and wilderness areas, in schools and meditation centers around the world. New voices were beginning to speak, the ancient language of cosmic wisdom. They spoke with the precision of modern instruments, but with the wonder of traditional sky watchers, combining technical knowledge with existential meaning, scientific rigor with spiritual depth. The conversation between human consciousness and cosmic intelligence that had been interrupted was resuming, finding new forms appropriate to contemporary conditions, while honoring the essential insights that previous generations had discovered. The stars that had been forgotten were being remembered, their ancient messages becoming audible again to ears that had learned to listen across the vast scales of space and time that connected every moment to the eternal dance of cosmic becoming. And, in that remembering, humanity was rediscovering not just its astronomical heritage but its cosmic identity. Not just techniques for observing the sky, but ways of participating consciously in the intelligence that moved the stars and guided the evolution of consciousness itself. The ancient astronomers had always known that to study the cosmos was to study oneself, that to understand the movements of the stars was to understand the movements of consciousness, that to align with cosmic rhythms was to align with the deepest purposes of existence itself. The echoes in stone and star continued to sound, their reverberations reaching across the millennia to touch contemporary hearts and minds with the same wonder that had driven humanity to first lift its eyes toward the infinite mystery of the night sky. The conversation between human and cosmos that had begun with the first conscious recognition of celestial patterns would continue as long as consciousness existed to participate in the eternal dance of becoming that connected every breath to the breathing of the universe itself. If this story stayed with you as you drifted off, support the channel by liking, sharing, and subscribing. We release weekly journeys into the forgotten, and every dreaming soul is welcome here.